Okay, so in this section, we are going to talk about slope as a rate of change and the average rate of change of a function. Okay, so when we talk about slope as a rate of change, we are looking at the change over time instead of looking at the small little increments. Kind of the best example that I can give is when you talk about little ones when they're born, the doctors want to see them a lot. They want to see them when they're like a week old, 2 weeks old, 4 weeks old, 6 weeks old, 8 weeks old, 3 months old, 4 months old, 6 months old, 8 months old, 9 months old, 12 months old, 15, 18, and then finally at 2 years. So, and when they go in, every single time they're going to measure their height and their weight and all these types of things. So one of the things, as a parent, is, they would give me these little charts every time. And they would talk about how my kid had, was in this or that or the other. And finally, one day I just looked at him and I said, from the time he was born to the time he is now, has he done what he's supposed to do? Don't talk to me about all the little bitty tiny things, okay? It's kind of like stock market stuff. You'll give yourself a coronary watching it every day, okay? But you're looking at whether or not you want to invest in something. You're looking at something over the long term of like over 3 months or 6 months or a year or however long. You're looking at the overall trending because there's going to be ups and downs every single day within the stock market, just the same way there's going to be ups and downs in a child, whether you happen to take them in right before a growth spurt or right after one or whatever else. So you're looking at that kind of overall trending for what's going on. And then for the average rate of change of a function, the idea here is we're changing that slope equation from y2 minus y1 to f of x2 minus f of x1. They're just going to give us an equation where we're going to need to find the values of those y2 and y1s, or that f of x2 and f of x1 values when we get ready to go into that. So the first one that we're going to look at is in 1990, 9 million adult men were living in the United States, lived alone. In 2008, we were at 14.7 million men were living alone. Use this information to find the slope of a linear function representing adult men who live alone. Express the slope correct to 2 decimal places and describe what it represents. Okay, so I've transferred this information over here to our lovely whiteboard. And so basically what we have going on here is this is going to be our x1, y1, x2, y2. So if we follow our slope formula, we're going to have 14.7 minus 9 over 2008 minus 1990. So it's going to be 5.7 over 18. And when we divide that down to 2 decimal places, we get 0.32. So there's our slope. Now what that represents, since it's positive, it means we increase by 0.32, and then look at the units here, million per, and then what was this unit over here? This was years. Okay, so we're basically breaking it down into this overall large increase of 5.7 over the 18 years could be broken down linearly into an increase of 0.32 per 1 year. Okay, so there is looking at that one as an average. Now, this next thing that we're going to look at is that average rate of change. Okay, so they're going to give us an f of x for this one. So they give us f of x equals x cubed, and they want us to find it from x1 equals -2 to x2 equals 0. Okay, so now formula, again, all we're changing out here is y2, y1. Remember, f of x is just another way to say y. So all we're doing here is trading kind of a fancier notation. So first off, I've got an x2, I've got an x1. So the bottom part of this I got to handle. I need to hash out the top part. So f of x2 is going to be f of, well, x2 is 0. So now I'm going to plug this in. So I've got 0 cubed, which is still going to be 0. Sorry, let me move that down just a little bit so you can see. And then I need f of x1, which is going to be f of -2. It's going to be -2 cubed. So -2 times -2 is +4 times -2 is -8. So now we're going to plug these things in. So f of x2 was 0 minus f of x1, which is -8, over x2, which is 0, minus x1, which is -2. So that's going to be 0 plus 8 over 0 plus 2. That's 8 over 2, which is 4. So there is our average rate of change.